Junior Cycle Higher Level 2014 Phase 3 Paper 1 Question 8. This is a sequences and series question. Straight away it asks you what sort of pattern is it? Is it linear, i.e. going up by a constant each time? Quadratic, where its second level differences are constant? Or is it exponential, whereby it's nothing to do with differences, it's actually multiplying one term to get the next? Well, let's have a little look at what's going on. We start off by checking to see whether it's linear or not. Do we check to see whether the differences between each term are constant? And we can see the first level differences are not constant, so it's not linear. So next look at is the second level differences. And since the second level differences are constant, i.e. they're going down by 0.8 each time, we have a situation where it is quadratic. Okay, the final test would be for exponential, and the way in which you approach exponential is you could always look at the common ratio, i.e. one term divided by the previous term. So if I were to do 3.4 divided by 0.3, if this is exponential, i.e. what would I multiply 0.3 by to get 3.4, I should notice if it were exponential, all these rational constants would be the same. And whilst for the first two terms, i.e. the second term is found by multiplying the first term by 11.33, its common ratio is 11.33. Well, let's see whether it's common. Let's look at another two points. Let's take the next one up, 5.7 divided by 3.4. Is 5.7 divided by 3.4 actually giving us a constant? And clearly we can see that there is no constant ratio. It's not going up by a certain amount each time. But sure, we knew that anyway. We didn't need to really do that. We knew for certain that it was quadratic because we found the second level differences were a constant. Now moving on to part 2, estimate the height of the ball after 3.5 seconds. So basically what we're wanting is the next term, 3.5. So we already know that we're taking away 0.8 away from the first level differences. So the first level differences, if we continue this on, is going to be minus 0.1 and minus 0.9. Finally, for the last one, it's going to be minus 1.7. So if we take 1.7 away from 6.9, we get 5.2. Going on to part 3, estimate the total time the ball spends in the air. Justify your answer. Well, we basically want to continue this as a process. Now, you could work out the nth term expression and equal it to 0, but I don't think actually the time taken to actually work out the formula for the nth term is worthwhile doing. It'd probably be quicker just working your way through, continuing as we just have done already, and continuing until we get a value for the height as being 0. So continuing on from 3.5, then we get for 4 seconds we get 2.7, and for 4.5 seconds we're going to get minus 0.6 technically. Now it's going to hit the ground. It's not going to become negative, but the key point is that it hits the ground at some point in time between 4 and 4.5 seconds. So we could just make a guesstimate, maybe 4.4 seconds. That's what it asked for. It asked for an estimate. So personally, I would go say sometime between 4 and 4.5, and then effectively just say I think it's 4.4 seconds.